Hello students, how are you all? I hope you are studying well and you have understood the physical properties as well as the chemical properties which we have discussed of the metals and non-metals, right? We have thoroughly gone through that. Even in the Zoom classes, it is all made clear. Now students, we are just going to discuss the third chemical property, that is the reaction with the acids, the reaction of the metals and non-metals with the acids. So student, as such, you people have seen that the metals, they react with the oxygen very well to make the metal oxide, which are basic in nature. Similarly, the metals, they react with the water, right, to make the metal hydroxide as well as the oxides along with hydrogen. Now we are going to discuss first of all the reaction of the metals with the salt, right? Salt, the obviously very reactive, like the hydrochloric acid. This is one of the very reactive acid as such, mineral acid. Similarly, the sulfuric acid we will discuss, and we will discuss why they do not react with the nitric acid, right? So now students, we are just going to start it with the third property, that is the reaction with acids. Now students, recall what we have done in the displacement reaction. In the displacement reactions, okay, I will explain you further later on. Now first of all, we are going to discuss about the reactivity series, activity series or the reactivity series, in which we come to know about it. Some metals are very reactive in nature as compared to the other metals. For example, sodium, potassium, these are highly reactive metals. They react violently with the oxygen, with the water, similarly as such with the acids, right? You know why they are very reactive? Because they are having a very low melting point, right? Even the sodium, potassium, they are always kept in the contact in the under the kerosene, in a bottle which have the kerosene, to make them inactive. In the school laboratories, as I have told you people, it is so corrosive in nature, we doesn't put it in the school laboratories, right? Because any sort of casualty may occur in the school as such. Now about the calcium and magnesium. Students, calcium also react with the acids very violently, right? It may be the hydrochloric acid, it may be the sulfuric acid. Then comes a category, in the category then comes magnesium. Magnesium reacts very fast, rapidly with the acid like the hydrochloric or the sulfuric acid to give the hydrogen. Students, when they react with the acids, maybe hydrochloric or maybe the sulfuric acid, they give hydrogen gas. And how we can come to know about the hydrogen is produced? You know, when we touch the, first of all, let us see the nature of the reaction. When we will touch the test tube or the beaker in which the reaction have occurred, it will be extremely hot without heating externally. Why it is hot? Because it is exothermic reaction. Heat will be generated when the reaction occurs. It will be released. Now, secondly, hydrogen will be produced. How we can test for hydrogen? When we will bring a burning splinter near to the mouth of the test tube which contain hydrochloric acid and sodium, potassium. Sodium, potassium in labs, I have told you, we don't know. We don't do. We actually do either the magnesium, zinc, etc. So that they cannot be so dangerous while conducting the experiment with the small children, right? Otherwise, whenever burning splinter is brought near to the test tube, it will burn like a possum, right? Now, I think it is very much clear to you people about the nature of the metals and their reactivity with the acids. Let us discuss with the equations. So, I have written metals react with acid to make their respective salts, right? Earlier, they make their metal hydroxides, metal oxides. Now, they will make the metal, or they will make the salts, right? Their salts and hydrogen gas. With the pop sound, I made you clear. So, metals above reactivity series, they displace hydrogen. Student, remember only the metals which are there above the hydrogen in the activity series. Why? Because all acids have hydrogen as the basic substance. You have done in your 7th standard very clearly in chapter acid, bases and salt, right? All the acids, they have hydrogen as the major substance. Clear? So that's why they displace hydrogen. Now after hydrogen, copper, silver, gold, platinum, mercury, they are coming, which do not displace hydrogen from the acids. Clear? Let us start with first sodium. First of all, we are just going to discuss about their reaction with the hydrochloric acid. Formula of hydrochloric acid is HCl. So when sodium reacts with the hydrochloric acid, this makes sodium chloride. Sodium chloride is a salt which is known to you people, common salt, right? It makes the hydrogen along with. Similarly, same kind of reaction occurs with the same balancing. I explained you balancing in my Zoom class very clearly. So potassium, K is the symbol for potassium. Potassium, when it reacts with the hydrochloric acid, this makes the potassium chloride, KCl, plus hydrogen will be there. Similarly, when the calcium this reacts with the hydrochloric acid, this makes calcium chloride, CaCl2, plus hydrogen will be produced. Now these three are at the top of the reactivity series and the reaction is highly violent in nature. It will be very dangerous reaction. That's why I was telling you people, it cannot be conducted in our schools labs as such for the security purpose, right? So it is highly violent. It can be dangerous any moment. Now we may do about the magnesium. Same reaction as the calcium have done. Magnesium reacts with hydrochloric acid to make magnesium chloride and hydrogen will be produced. How we can test hydrogen? By bringing the burning splinter near to the mouth of the test tube. It will burn with the pop sound. I told you what is a pop sound? Like a cracker is burst, right? Slight that kind of sound will be produced, but that is called the pop sound. Now students, in the same way as they reacted with the hydrochloric acid, same way metals they react with the sulfuric acid. That is, when sodium reacts with the sulfuric acid, it makes sodium sulfate. Na2SO4 is the formula. Again, it's a salt. When chloride, sulfate, nitrate, they comes at the end of the formula, that is the salt. You have done in acid, bases and salts. The formula which starts with the H is the acid, which ends with the OH is a base, which ends or neither starts with H nor ends with OH, right? So that is called a salt, right? So this is a salt which is again produced hydrogen. Maybe it reacts with the hydrochloric acid, maybe it reacts with the sulfuric acid. They form hydrogen acid. Now calcium, when reacts with the sulfuric acid, make calcium sulfate and hydrogen, right? See the reaction very clearly. Zinc. We normally used to do the experiment with the zinc. It's quite safer as such, right? When we put the granules of the zinc, in our lab we have the zinc powder, zinc dust also. We put the zinc dust in a test tube and we put the hydrochloric or the sulfuric acid in the zinc. We will observe that immediately the reaction occurs with the effervescence. Effervescence means bubbles. Immediately the bubbles will start producing and they will start rising in the test tube. That's why we used to put the keep the test tube in a holder, in a test tube holder, so that our hand may not be burnt, right? So what happens? The effervescence, the bubbles immediately start producing, right? So and when they will start producing, we will bring a burning splinter near to the mouth of the test tube. It will burn with a pop sound. A pop sound is produced. That is the indication that the hydrogen have produced, the reaction have occurred. And now simultaneously we will try to touch the test tube. It will be extremely hot. We have not kept it on the flame, but even then it is hot because the reaction is highly exothermic in nature. So aluminium, this also reacts with the sulfuric acid to make Al2SO4 thrice is the formula for aluminium sulfate, and hydrogen gas will be produced. Students, nitric acid is again one of the very important and reactive acid, but it do not react with the metals. The reason behind is, in your senior classes you will learn about the oxidizing agent as the reducing agents. So जो nitric acid है, this oxidizes, right? It will act as the oxidizing agent, means it gives oxygen to the hydrogen to make water, right? So hydrogen will not be produced in this reaction and it itself reduces into the nitrogenous compounds like NO2, nitrogen dioxide, nitrogen trioxide, dinitrogen monoxide and so on, right? Means always remember, it will oxidize the hydrogen to the water and itself reduces. means the compound itself will be broken. That's why it is not reacting with the metals. Now, let us discuss of the non-metals. Non-metals, they generally do not react with the acids. Reason, I told you in my last lecture also, the reaction of the non-metals with the water. Here also the same is there as hydrogen. Hydrogen basically is a non-metal, means acceptor of electrons, and non-metals are also acceptor of electrons. That's why they do not react with non-metals. But at the particular conditions, the metals like the sulfur, carbon dioxide, etc., they react with the nitric acid, not the sulfuric or hydrochloric acid. They react with the nitric acid to make sulfur dioxide, nitrogen dioxide, and water. Similarly, in the case of the carbon also, but the reaction will not be stable in nature. So, general statement is here, non-metals generally do not react with the acids. Right? I think it is very much clear to you people now about the metals, their tendency, the reactivity, exothermic reaction, valent, and so on. So just try to just see the equations. Try to just do the practice of the equation in your notebooks. Thank you, students.